Hey everyone, welcome back to another Edexcel IAL Maths past paper video. Today we're going to talk about the Pure Maths 2, which is P2 from the October-November 2024 series. So let's jump into the paper. Question number 1. A continuous curve has equation y equals to f of x. A table of values of x and y for y equals to f of x is shown below. So there we have the values. Using the trapezium rule with all the values of y in the given table, find the estimate for basically the area under the curve from 0.5 to 5.5. Now we know the formula for this, which is h over 2. H is the bin width. The first and the last value come only once, but all the rest to the second last come twice. So basically this is what we need. We also need h. So before we actually go, because these are a set of values, I need to copy them first before we write into the answer space. H is basically usually 5.5 minus 0.5 divided by, this is bin 1, bin 2, bin 3, bin 4, but we don't need this actually. We already have this. 1.75 minus 0.5, 3 minus 1.75, 4.25 minus 3. This is going to be 1.25. You can actually see this also. So 5 divided by 4, this would be 1.25 also. So we would have gotten the same thing anyway. Right, so just to write over here, just so I don't make a mistake. So 1.25 divided by 2 times by 3.479 plus 5.182, plus 2 times by, now the values that are coming twice, 6.101 plus 7.448 plus 6.823. All right, now we need to write it over here. So h is 1.25. So the integral of this f of x dx can be approximated by h over 2 y naught plus yn plus 2 times by y1 y2 plus, we actually have just like 3 values, so we can do this over here. So we have 1.25. This is an approximation, so if you use this also, that would also be fine, divided by, now we need the values, 3.479, 5.182 plus 2 times by 6.101 plus 7.448 plus 6.823. Right, and this is coming out to be 30.878125, or the value is 9881320. So we can rewrite it as 30.9. Okay, because we were supposed to give the answer to 1 decimal place. Okay, using your answer to part A and making your method clear, estimate. Okay, so same thing but with 4x added. Okay, so we have 0.5, 5.5 f of x dx plus 4x. So remember, we can split this because integration is a linear function, so we could have done this dx. So the first one is approximate to 9881 divided by 320 plus, now 4x integral is 4x squared over 2, which is just going to be 2x squared over, from 0.5 to 5.5. So now we need the value 9881 320 plus. So remember, intermediate values, we can choose a higher accuracy. We can use exact forms also. So 2, you have 5.5 squared minus 2, 0.5 squared. So this plus 2 times by 5.5 squared minus 0.5 squared. So you have 29081 over 320, which can be approximated to 90.9. Right. Okay. So that is basically the answer. Any other part? No. All right. So this is question number 1. Now on to question number 2. Question number 2. A sequence of numbers u1, u2, u3 is defined by u1 is equal to 7 and un plus 1 is this, where k is a constant. Show that u5 is 7. Okay. So what we do over here is we need to make go from u1. We need to figure out the other ones also. So u2 would be, you see, the previous value plus k. So see, this is n plus 1. So this would be minus 1, 1. Un is 7. Plus k, this would be minus 7 plus k. u3 would be minus 1 squared. Un is minus 7 plus k. Plus k, so this is minus 1 whole squared is just 1. So minus 7k plus k is minus 7 plus 2k. u4 is going to be minus 1 cubed and minus 7 plus 2k plus k. So you see this would become minus 1. So minus 1 whole cubed is minus 1. So minus 1 times by the bracket is 7 minus 2k plus k, which can be simplified to 7 minus k. And u5 is minus 1 whole raised to power 4, 7 minus k plus k. So minus 1 whole raised to power 4 is just 1. So 7 minus k plus k, basically that's 7. So that's what we have shown. So therefore u raised 5 is 7. Now given that the sum of terms from r is equal to 1 to 4, that means first 4 terms is 30. Find the value of k. All right. So this means that ur is equal to 7 plus minus 7 plus k plus minus 7 plus 2k and then plus 7 minus k. Now 7, so we can drop the brackets for some of them. This is gone, this is gone, and this is gone. So we get 7 minus 7 is 0, and also minus 7 plus 7 is 0. So this is equal to 30. So k minus k also 0. So we are left with 2k equals to 30. So k is 15. Right? Okay. Now find the value of k. All right. Hence find the value of the terms from r1 is equal to 1 to 150. That means for the first 150 terms. So let's examine how the terms actually look like. So we have 7. First term was 7. Now if k is equal to 15, let's write over here. So this is 7 minus 7 plus k, 15 minus 7, 8. 30 minus 7, 23. 7 minus 15, minus 8. And this is 7. Oh, okay. So this is a periodic sequence. So this is one period. Basically 4 terms in each period. Alright, so basically you have 7, 8, 23, minus 8, and basically one period. This is your one period of this sequence. Because after that 7 would repeat and then you will get 8, 23 and minus 8 again. Right, okay. So we need to see how many terms, how many periods are in this. So number of periods would be 150 divided by 4. So 150 divided by 4, 37.5. So 37.5 means 37 full periods and 1 half period. Okay. So, right. So this would be sum from 1 to 150 UR would be 37 times by the values from 1 to 4 UR, which is 30, plus U1 plus U2. Okay, so we have 37 times by 30 plus 7 plus 8. So 37 times by 30 plus 7 plus 8, which is 1125. Right, so this is the question number 2. Now on to question number 3. So we further do this, that you have 2 minus 3 cubed minus 3 squared plus a times by minus 3 plus b, and that is equal to 55. So minus 3 cubed is 27 positive, sorry, minus 27, and then minus 3 whole squared is just 9, minus 3a plus b. So 27 times by 2 is minus 54, minus 9, minus 3a plus b equals to 55. So you have 55 plus 54 minus 9, no, plus 9, sorry. That is 118 equals to minus 3a plus b. Now after that you can multiply both sides by minus 1, getting you 3a minus b equals to minus 118. Right, okay. Given also that 2x minus 5 is a factor of f of x, that means f of 5 over 2 would be 0 using the factor theorem. So, right, okay. Find the value of a and b. Okay, so basically we have another condition to solve simultaneously. So f of 5 over 2. So we have 2 5 over 2 cubed minus 5 over 2 squared plus a times by 5 over 2 plus b. Okay, so 2 times by 125 over 8 minus 25 over 4 plus 5 over 2a plus b, and this is equal to 0. Right, okay. 2 times by 4, so 125 over 4 minus 25 over 4, that will lead us to 100 over 4 plus, let's make denominators the same for on both sides because the other side is 0. So 2 times by 2 is 4, so 5 times by 2, 10a plus 4b. Now that is equal to 0. So now we can cancel out the 4 on all sides. So basically we can multiply both sides by 4. So you will get 10a, therefore 10a plus 4b equals to minus 100, which you can simplify to 5a plus 2b equals to minus 50. Right, okay. Right, now we need to solve them simultaneously. So this is our second equation. So first one we had 3a minus b equals to minus 18. Now you have 5a plus 2b equals to minus 50. So what we can do over here, that we can multiply this equation by 2, getting us 6a minus 2b, and 118 times by 2 is 236, so minus 236, and you have 5a plus 2b equals to minus 50. So we just need to add these equations up. 6 plus 5, 11a equals to minus 286. So 236 plus 50, right, okay. So minus 286 divided by 11 is minus 26. B, however, would be 3a plus 118. So 3 times by minus 26 plus 118. So 3 times by minus 26 plus 118 would be 40. Right. Okay, so therefore A is minus 26, B is 40. Okay. Hence, find the quotient when f of x is divided by x minus 7. So we need a quotient over here, so we can do the long division now, because we have a and b now. So f of x was C part two x cubed minus x squared plus ax, so minus 26x plus 40. Now we need a quotient when f of x is divided by x minus 7. So long division over here, so 2x cubed minus x squared minus 26x plus 40, and x minus 7. Right, okay. So we start with the first term, so we need to multiply this with 2x squared to make it 2x cubed minus 14x squared. So when we subtract, signs will change, so you will get 14 minus 1, that is 13x squared minus 26x. So now we need to multiply with 13x, so we will get 13x squared, and 13 times by 7, that is 91x. So again, signs change. So 91 minus 26, 65x plus 40. And then we multiply this with 65 to get 65x, and 65 times by 7. That is 455. So this cancels. So 455. So we will get 495 remainder. So the quotient would be 2x squared plus 13x plus 65. And that was the C and the last part. Okay, on to the next question. Question number 4. The curve C has equation y is equal to this. Find dy by dx giving each term in the simplest form. So we have this. So y equals to 4x half plus 9x minus half plus 3x greater than 0. Okay, so first we do the dy by dx. So dy by dx, so half comes down, so you have times by 4x minus half. Then you have a minus that comes down, times by 9x minus 3 by 2, and the derivative of 3 would be 0. So let's simplify this. So 4 divided by 2 is just 2x minus 1 over 2 minus 9 over 2x minus 3 by 2. So this is your dy by dx giving each term in its simplest form. Find the x-coordinate of the stationary point. Okay. So you have at stationary point. So at stationary point, we know that dy by dx would be 0. So therefore, we need to see what happens at minus 9 over 2x minus 3 by 2 equal to 0. So there are two ways to do this. We can combine, we can somehow rearrange the equation to make x the subject, or we can make it sort of like a quadratic equation. So let's try method number 1. This simple rearranging. So you will get 2x minus 1 over 2 equals to 9 over 2x minus 3 by 2. So make the ratios of x. So x minus 1 over 2 divided by x minus 3 by 2. 2 comes over here, you get 9 over 4. This becomes minus 1 over 2 minus 9 over 4. So this becomes x minus half plus 1.5 is just 1. So this is 9 over 4. Now method 2 would require similar process but likely in a quadratic form. So we know that you have powers minus 0.5 and minus 1.5. So to make the powers into integer forms, we need to add them both with 1.5, positive 1.5. So what that means is we need to multiply both terms with 2x 3 by 2. So 2x and divide by 2 because we need to get 2 in the denominator. So this becomes 2x minus 1 over 2 minus 9 over 2x minus 3 over 2 equal to 0. You will get 4 x. We see 1.5 minus 0.5, that is just 1. Sorry, this is not getting us quadratic. Oh, okay, so this is 9x raised to power 0. Basically that would be just 1 equal to 0, so therefore x equals to 9 over 4. Yeah, so both ways we are getting the same answer. Okay. Right, find d squared over y over dx. No, sorry, b part is, okay, no, we're done. Find d squared over y dx squared, giving each term in its simplest form. So c part 1. So dy by dx was 2x minus 1 over 2 minus 9 over 2x minus 3 by 2. Just to make sure that that's what we had. Right, okay. Now we need d squared y over dx squared, double derivative. So minus half again comes down, and this power goes further by 1, and 3 by 2 comes down, minus 3 by 2x, and this becomes minus 5 by 2. So 2 and 2 get cancelled, leaving us with minus x minus 3 by 2, and this one becomes 27 over 4x minus 5 by 2. And there's no further possibility or further process for any further simplification. This is the simplified form. Right, okay. Hence determine the nature of stationary point C, giving a reason for your answer. Okay, so x is 9 over. So d squared y dx squared at x is equal to 9 over 4. So this becomes minus 9 over 4 minus 3 by 2 and plus 27 4 9 over 4 minus 5 over 2. So we need to see this. So minus 9 divided by 4 raised to power minus 1.5 plus 27 over 4 brackets again 9 divided by 4 raised to power minus 2.5. So you're getting 16 over 27, which is greater than 0. So therefore d squared y dx squared greater than 0. So therefore it is a minimum point. Right. Okay. State the range of values of x for which y is decreasing. So, right, for which y is decreasing. So if it's a minimum point, so for like x greater than 0, only for x greater than 0, you are getting this point somewhere over at 9 over 4, x is equal to this. We don't know how the curve is going after this. So it's a state question, not much working is required. So this would be in between from this to this. And it says decreasing, so it doesn't include the minimum point. So we can say f prime of x decreasing, we need this less than 0, for which y is decreasing, right? So we need to just state it. However, you can do the working for that also. It's not necessary though. You can still work that out. You see, when you do the less than 0, you would still get this, but instead of equal to 0, you have less than 0. So you would still get x less than 9 over 4. So basically you would get a combination of x greater than 0. X greater than 0 is already a given solution, and you need to have a intersection with x less than 9/4. So basically you would get 0 less than x less than 9/4. Okay, and that's the last part of this question. So let's move on to the next one. Question number 5. Find, in terms of a, the first three terms in ascending powers of x of the binomial expansion of 2 plus ax 6, where a is a non-zero constant. Give each term in the simplest form. Okay, so this is easy, straightforward. 2 plus ax 6. The general form of each term would be 6c0 in ascending powers of x, right? So we are starting with 2 raised to the power 6 and ax raised to the power 0 plus 6c1, 2 raised to the power 5, ax raised to the power 1 plus 6c1, 2 raised to the power 4, ax squared, and these are the first term. So we need to simplify this. So 6c0 is just 1. So 2 raised to the power 6 is 64, I guess. Yes. So 1 times by 64 is 64, because ax raised to the power 0 would also be just 1, plus 6c1, so 6c1 times by 2 raised to the power 5, which is 32, so 192 ax, and then this is 6c2, so 6c2 times by 2 raised to the power 4, 16, which is 240 a squared x squared. Right, okay. Given that this f of x is 3 plus 1 over x whole squared plus 2 plus ax raised to the power. Given that the constant term in the expansion of f of x is 576, find the value of a. Find the value of a. Okay, so basically what we can do is we can do the expansion of the square first and then see which terms would correspond to the constant term or contribute to the constant term. So 3 plus 1 over x whole squared would be 9 plus 2 times by 3, 6 over x plus 1 over x squared. So to contribute to a constant term, there will be okay, so constant term, that means where x is equal to power 0, so that would be when 9 is multiplied with 64, and then when 6 over x is multiplied with 192 times by ax, so 6 over x times by 192 ax, and then when 1 over x squared is multiplied with 240 a squared x squared. So now we just need to simplify this. Right, okay. So this would be 9 times by 64, that is 576, plus 6 times by 192 is 1152a, and then 240 a squared. So this is your constant term. Okay. This is equal to 576 itself. So this is all equal to 576. So this would mean, sorry, this is 240 a squared. So this would mean that this thing is equal to 0. So 1152, this is a quadratic equation now, plus 240a is equal to 0. Is a one answer would be a no 192 ax, right. So find the constant. Okay, alright, they did say a is a non-zero constant. Okay, alright, so that's fine. So we are only concerned with this one. So 1152 plus 240 a equal to 0. So therefore a would be minus 1152 divided by 240. So minus 1152 divided by 240 would be minus 24 over 5, or minus 4.8. Okay, that's it. Right. Find the value of it. Okay, so that's question number 5. Let's move on to question number 6. Okay, question number 6. Using the laws of algorithm. Question number 6. Using the laws of logarithm, solve log base 4 12 minus 2x plus 2 log 4 x plus 1. Okay, so multiple ways to solve this. The easy way is to bring all the log terms on one side and then reverse the log. So you have log raised to power 4 12 minus 2x. This is your 2 plus the square can go over here, log 4 x plus 1 squared. Right, okay. We bring the terms on one side, so log 12 minus 2x minus log 4 x plus 1 whole squared is equal to 2. So this can be rewritten as 12 minus 2x divided by x plus 1 whole squared, and this is 4, equals to 2. Now we reverse the log, invert the function. So turning logarithmic equation into exponential form. So this is easy. This would be this is the base, this is the log or the exponent. The 4 raised to power 2 is equal to 12 minus 2x x plus 1 whole squared. Right, okay, so we expand and we take on the other side, so 16. This would be x squared plus 2x plus 1, 12 minus 2x. So let's simplify. 16x squared, 16 times by 2 is 32x plus 16 times by 1 minus 12 plus 2x equal to 0. So this becomes 16x squared, 32 plus 2 is 34. X, and 16 minus 12 is 4 equal to 0. All of these are divisible by 2, so 8x squared, so divided by 2 basically, plus 17x plus 2 equal to 0. Now we need to solve this quadratic equation. Is there any, okay, let's see if we can make use of sum and product rule. I think we can. So 8 times by 2, 8x, x, and 1. Yeah, straightforward. So 16x plus x, right. There's no need for quadratic formula. So 8x plus 1, x plus 2 equal to 0. So either x is minus 1 over 8 or x is equal to 2. So did they give us any condition for this? Okay, alright. So we need to see which condition actually works for this also. So did we make a mistake over here? 8 times by 2 is 16. X 17 plus 2. Right, okay. So we need to test both of these, basically which one of them turns it into a negative. So you have log. For them to satisfy, they have to be 12 minus 2x has to be greater than 0, and so does the x plus 1 has to be greater also. So if we choose x is equal to minus 1 over 8, you get 12 minus 2 times by minus 1 over 8. So 12 minus minus becomes plus, and 2 divided by 1 over 8 becomes 1 divided by 4. This is 49 over 4, so definitely greater than 0. And if we choose the same one, 1 minus 1 over 8 would definitely be 7 over 8, which is greater than 0. So this answer is fine. Let's check the other one. 12 minus 2 greater than 0. So x plus 2. Oh, no. Oh, wait, this was minus 2, sorry. Yeah, okay. So if you have minus 2, you get, although this would be 12 plus 4 greater than 0, but it will not satisfy the other one. So minus 2 plus 1, that is minus 1, so that is less than 0, so that means this equation, this solution will be discarded. So therefore, x will be minus 1 over 8. Right. And that was question number 6. Let's move on to question number 7. Question number 7. Jem pays money into a savings scheme A over a period of 300 months. Okay. Jem pays 20 into scheme A in month 1, 20.50 in month 2, 21 in month 3, and so on, so that the amount Jem pays each month form a arithmetic sequence. Show that Jem pays 69.50 into scheme A in month 100. Okay. Right. So this is an arithmetic progression. So A is 20. And right, D is 0.5. So UN is going to be A plus D times by N minus 1, so that is 20. Actually, we just need U100 now. So that would be A plus 100 minus 1 D. So that would be 20 plus half of 99. So 20 plus 99 divided by 2 is 69.5. Is it what they asked? Yes, 69.5. Sure. Okay. Right. Find the total amount that Jem pays in the scheme A over a period of 300 months. Okay. So that means we need sum to first 300 terms. So we know the formula. That is going to be, let's write over here just for reference. So Sn is n over 2, 2a plus d times by n minus 1. So 300 divided by 2, 2 times by 20 plus 0.5, 300 minus 1. So 300 divided by 2 is 150. 2 times by 20 is 40 plus half of 299. So 150 times by 40 plus 99 divided by 2, that is 13,000 n divided by 2. 2a plus wait a sec. Oh, sorry, this is 299. My bad. This is 299. 299. So right. Okay. So 28,425. Right. Okay. Kim pays money into savings scheme B over the same period of 300 months. In a model, the amounts Kim pays into scheme B increase by the same percentage each month. So this is geometric progression. So that the amounts Kim pays each month form a geometric sequence. Okay. Given that Kim pays 20 into scheme B month 1, 250 into scheme B month 300. Okay. Use the model to calculate to the nearest 10 the difference between the total amount paid into scheme A and the total amount paid into scheme B over the period of 300 months. Right, okay, so first off we need the sum to 300 for geometry. That means we need to find out what the common ratio is also. So that is part C. You have a geometric sequence un is equal to AR n minus 1. So the A was 20. They said that, same as scheme A, and the month 300 would be 250. Right. So U 300 is 20 times by R 300 minus 1, 299. That is 250. 250? Yes. Okay. Now we need to calculate what that means. So R299 equals to 250 divided by 20. So this is 25 divided by 2 is 12.5. Right, okay. And now we can do log over here also. Either way that would be fine. So 299 log of R equals to a log of 12.5. So you have log R. This is base 10 basically. So we can do 1 over 299 log of 12.5, and then we can do actually this was useless, can't believe okay, that's fine, we can do that. Okay, never mind. So now we can do 10 raised to power this, and then 10 raised to power this. Okay, so we find out first. So 1 R would be that. So log of 12.5 divided by 299, and then 10 raised to power answer would be 1.008483. So basically R is that. We can save it into the answer also. I think it would have been easy had we done the simple 12.5 raised to power 1 over 299. Basically that's exactly what this would mean. R is equal to that. Okay. Now we need the sum to 300 terms. We have a 1 minus r n over 1 minus r. So we would need let's use the exact value over here. The 1 minus 1.008483 raised to power 300 divided by 1 minus 1.008483. Okay, let's save this value in the calculator so we don't have to write it again. Oh, no. Oh, okay, never mind. So you have 12.5 raised to power 1 divided by 299. So let's save this. Okay, now we can do that. So 20 times by 1 minus answer raised to power 300 divided by 1 minus answer. We get 27,362,948. Okay, so difference would be what was the for the 28425? 28425 minus 27,362.948. Right, okay, so 28425 minus answer is 1062.052. So basically I think we can just say, wait a second, wait, I think they gave us something to say, to the nearest 10. Okay, so this would be, can be written as 1060. Final answer. Right. And that's it for question number 7. Now let's move on to question number 8. Question number 8. Figure 1 shows a sketch of part of the curve C1 with equation y equals to x squared plus 3 and part of the curve 2 with equation 13 minus 9 over x squared. The curves C1 and C2 intersect at points P and Q as shown in figure 1. Use algebra to find the x-coordinate of P and x-coordinate of Q. Okay. So we just have to simultaneously equate them, or equate these conditions. So this would be equal to 13 minus 9 over x squared. So what we can do is we can multiply both sides by x2 to get x raised to power 4 plus 3x squared equals to 13x squared minus 9. We bring everything on one side. You have x raised to power 4 minus 10x squared plus 9 equal to 0. So now we can replace temporarily with x squared. So we can solve this as normal quadratic equation. Product is 9, sum is minus 10. A, and this is your a squared. You have a 1 minus 9 times by minus 1, that would be just positive 9, and minus 9a, and minus a would give us minus 10a. So basically you have x squared minus 9 and x squared minus 1 equal to 0. So either x squared is equal to 9 or x squared equals to 1. So we have quite a lot of options. So x would be either plus minus 3 or x is equal to plus minus 1. Since both of these functions are greater than 0, since x is greater than 0, so therefore x coordinate of p would be 1. X coordinate of p is 1 and x coordinate of q would be 3. Right, okay. The finite region R, shown shaded in the figure 1, is bounded by C1 and C2. Use algebraic integration to find the exact area of R. So C2 minus C1, basically. So B part, you have 1, 2, 3. This is 13 minus 9 over x squared minus x squared plus 3 dx. So what we can do over here, be careful with the sign. So this can be, so we can rewrite it as this would go, but this would become minus. Now we can remove the brackets. Right, okay, now we can integrate it easily, so you can even do this as minus 2. Alright, now integration is straightforward. So 13x and minus 9x raised to the power minus 1 over 1 minus x cubed over 3 minus 3x from 1 to 3. This is not the simplified form. Let's simplify it first. So 13 minus 3x is 10x. Minus minus gets cancelled, so this becomes 9 over x. And this is 1/3 of x cubed. Right, now we are ready to plug in the values so that we don't make any mistake. Now, 10 times by 3 plus 9 over 3 plus 1/3 of 3 cubed minus 10 times by 1 plus 9 over 1 plus 1 over 3 times by 1. You get 30 plus 3 plus, this becomes square, so 9 minus 10 plus 9 plus 1 over 3. So you have 30 plus 3 plus 9, minus 10 minus 9 minus 1 divided by 3, 68 over 3. This was minus. Why? Just a minor mistake. Minus, 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 minus. So this is minus, minus, and minus over here. Okay, so 30 plus 3 minus 9, and then minus 9, and this is plus. Sorry, I was making a sign mistake all over. So this is just 16 over 3. Okay, alright. That was part B. Okay, now on to question number 9. Show that the equation 2 tan theta is equal to 3 cos theta can be written as this. So notice that we're turning this into an equation of sine squared. Okay, so we know tan theta can be written as sine theta over cos theta. So 2 tan theta can be written as 3 cos theta can be written as 2 sine theta over cos theta equals to cos theta. Now cross multiply, you get 2 sine theta equals to cos squared theta. Okay, now we can use the identity. So cos squared theta would be equal to 1 minus sine squared theta. So once you plug this in, you will get 2 sine theta is equal to 1 minus 3 cos theta, 3 cos 1 minus sine squared theta. So you have 2 sine theta equals to 3 minus 3 sine squared theta. You get 3 sine squared theta plus 2 sine theta minus 3 equals to 0. That was the first part, right? 3, 2, and minus 3 there. Hence solve for minus pi less than x to pi equation this, giving your answers to 3 significant figures. Okay, so first we need to solve it as it is, and then we, instead of theta, we plug in 2x plus pi by 3. Okay. So we have the equation. Let's see if we can find the answer in sum and product rule. So you have 3x, 3xx, and 3, 1. No. Okay. Let's try out with the quadratic formula. So minus b plus minus b squared minus 4ac. So 4 times by 9, 36, and would be positive because of the minus 3. You have 2 times by 3, 6, minus 2 plus minus square root of 40 is 2 root 10 divided by 6. So you have either minus 1 over 3 plus minus 1 over 3 root 10. So basically sine theta is minus 1 over 3 plus minus, like either it is plus 1 over 3 root 10, or another possible answer is minus 1 over 3 minus root 10 over 3. Okay, so let's see which one of them is possible. So minus 1 divided by 3 plus root 10 divided by 3. So this is possible, right? So minus 1 plus minus root 10 over 3. This is possible, but what if we do minus over here? This would not be possible, right? So we, no, this was plus. Okay. I don't know what's going on. It usually clears out easily. Okay. Never mind. Right, okay. Now we need to do the sine inverse. Plus. So theta, the primary angle, comes in sine inverse and we also need it in radians. So answer is 0.8049. Okay, now we need to see what do we need for x. 2x plus pi by 3. Okay, so first off we need to see how the 2x plus pi by 3 range will go, like the theta range will go. So now let's say theta is 2x plus pi by 3. So if x is between pi to minus pi or minus pi to pi, 2x would be from 2 pi minus 2 pi and then pi plus 3, so minus 2 pi plus pi by 3, 2x plus pi by 3 and 2 pi plus pi by 3. So pi by 3 is basically 60, so in degrees minus 360 plus this is minus 300 and 2 pi plus this is 420 basically. So in degrees this would be this case. Now we just need to see some possible answers for theta in this range. So from minus 300 to 420. So we can do this with the help of the graph also, and we can do this with the help of Gauss diagram also. So if we do this with the graph, that would be the easiest and the most sensible thing to do. So the graph of sine goes, now this is not going to be the exact form, but at least something. Right, okay. So the first answer is coming as 0.8049, which is less than pi by 2, right? Yeah, so less than pi by 2. So first answer is actually coming over here somewhere. 0.8049 radians. So this means that this value sine theta that we actually got, so that was minus 1 divided by 3 plus root 10 divided by 3. This is 720. So basically you can see this is going to be cutting the sine curve in these places. So let's see which one of these would we need. So this is a pi, this is 2 pi, this is 3 pi, 4 pi. We don't actually need that much. We just need up till this part. And from minus 2 pi, so this is pi. Well, actually I have to see which, like, do we actually need this or not. Maybe we won't, but let's see. So we have 1, 2, 3, 3 from one side, this one, and possibly this one we will see from equations. Now, how do we actually go from the one that we have done to the other one? So let's use another different color. So we know that plus 2 pi will get us this, and minus 2 pi will get us, will get us this one. So first let's do this and see what we get. So 0.8049 plus 2 pi is 0.8049 plus 2 pi is 7.088. 0.8049 minus 2 pi. First we are going to collect then we will make sure what we need. Minus 5.478. Right, okay. So we have gotten these three now. Now we need this one. So you see, this would be pi minus 0.8049. So pi minus 0.804. This particular one will also be minus 2 pi, and we will get this one. So you have pi minus this minus 2 pi, so this, and then minus 2 pi. First we need this one. You have 2.337. We also have the original 8049, and then you have pi minus 0.804 minus 2 pi. You get a minus 3.946. Okay, so these are still just theta. We actually haven't gotten to solve the x yet. So we will get back to x in a second. So all of these are just theta, which is the transformed function. So the doubt is on this one. So let's see what value do we get. Minus 2 pi plus pi divided by 3. It's actually, let's use the radian value. Minus 5.236. And, right, okay, and then 2 pi, this is going to be 7.330. So which one of these would be selected? So let's use green. Okay, green. So this would be selected, this would be selected, this will not be selected, this would be selected, this would be selected. Okay, so theta values we have are therefore 0.8049. No. Let's go from left to right. Minus 3.946. 0.8049. 2.337, and then 7.088. Okay, so now we need to see what transformation do we actually need. So we need 2x plus pi by 3. Okay, so we need the x values now. So x would be, so if theta is 2x plus pi by 3, so therefore x would be theta minus pi by 3 divided by 2. Theta minus pi by 3 divided by 2. Okay, so x values would be, right, okay, so 0.5 minus pi divided by 3. Now theta 1 by 1, so minus 3.946. The one value is minus 2.497. We'll round it in a second. We just first need the values. 0.8049. This is minus 0.121. And then we have 2.337. 0.6449 and 7.088, 3.020. So right, So basically these are the values that we would obtain for these particular values. So okay, so now we need to give them in 3 significant figures. Okay, so this will be rewritten as minus 2.50, minus 0.121, then we have 0.645 and 3.02. Now notice that this was easy to work with from the sine graph, sine theta graph. This is your y, this is your theta, because you could see the big picture over here. If you had done this or attempted using the cos diagram for this, you might have stumbled and made mistakes. So graph lets you see the big picture. Right, okay, so this is this question. Let's move on to the next one. Question number 10. The circle C has equation x squared plus y squared plus 4 minus 30y plus 209 equal to 0. Find A, the coordinates of the center of C and the exact value of radius of C. So basically we need to go from expanded form to the squared form. So first we will write x squared plus 4x y squared minus 30y and minus 209. Right, now we need to complete the squares for this one. Actually we don't. So x squared plus 4x plus 4 divided by 2 is 2. 2 squared is 4 minus 4 plus y squared minus 30y. 30 divided by 2 is 15. 15 squared is 225 minus 225 equals to minus 209. You will get x plus 2 whole squared plus y minus 15 whole squared equals to minus 209 plus 225 plus 4. So let's see what we get. So minus 209 plus 225 plus 420. Okay, so this is the radius squared. So center is minus 215 and radius is square root of 20 because they asked for the exact answer. Okay. The line L has equation y is equal to mx plus 1 where m is a constant. Given that L is tangent to C at point P, show that find the possible pairs of coordinates of P. Tangent to C at point P means that it's meeting the curve at only one point. So we know that we would have to plug in this mx plus 1 into the equation, and that would be a very long equation. Let's see alternatively what we can do over here. So you have minus 215 over here, so let's try to make a diagram before we make sure that there is no other way. So minus 215 somewhere is over here, right? And what else? And that is y is equal to mx plus 1. Radius is square root of 20, so basically it would be Let's assume that it's cutting the x-axis somewhere. Somewhat like this, I don't know. I think we can find out. So let's see. Plug in x is equal to 0. You get y squared minus 30y plus 209 equal to 0. I don't want to solve this. I just we just need to see how this would look like. So y is equal to mx plus 1 is basically just a tangent. So however it looks like, so that would mean that y is equal to mx plus 1. Oh, sorry, no. Is either going this way or, wait a second. Or it's going, did they say what m is? Okay, so they did not. Okay, so either this or possibly this also. This would also be the correct way to do this. Right, like this. Okay, so it could have a negative gradient also. Alright, so before we actually do anything, let's see the properties that we have. It may not actually look like this. This point could be lower than this also over here, because this is 15, and oh my god, we actually made it wildly different over here. So this is going right over here. Let's make it slightly realistic, like this. Okay, maybe like this. Okay, this is fine. And this would be like this. Okay, because this is 15. I just realized this is 15 and this is 1. So obviously we would have points of tangents over here. What circle theorem properties we can use that may be easier than doing the simultaneous equation, because simultaneous equation, although it might give us the solution, but I do not want to use that at the moment. So we have minus 2 comma 15 over here and 0 comma 1. There could be a line joining this point, and we also know that the points of tangent are perpendicular to the tangents are perpendicular to the radii this way. You have x plus 2 whole squared plus y is your mx plus 1 minus 15 whole squared equals to 20. X squared plus wait, this becomes x plus 2 whole squared plus mx minus 14 whole squared equals to 20. So x squared plus 4x plus 4 plus m squared x squared minus 28 mx plus 14 squared is 196 equals to 20. Right, okay. Let's simplify. You have m squared plus 1 x squared, 4x 4 minus 28 mx, and 4 plus 196 200 minus 20 is 180 equal to 0. Now we know that this is touching the curve at only one point, so b squared minus 4ac is equal to 0. So 4 minus 28m squared minus 4m squared plus 1, 180 equal to 0. So 16 minus 2 times by 4 times by 28 is 224. 28 squared m squared minus 180 times by 4, 720 m squared, and then minus 720 equal to 0. Right, okay, now let's simplify. So 784 minus 20, that is just 64. 64 m squared minus 224 m, and then 16 minus 720, this is minus 704. I feel like we're making a mistake somewhere. Okay, anyways, is 224 divisible? Oh, no. Is 224 divisible by 64? 7 over 2. 48? No. 4? 56. I want to simplify all of them at the same time. So let's first divide them by 2. So 64 divided by 2 is 32. 224 divided... Oh, why does it keep doing this? 224 divided by 2 is 112. And minus 704 divided by 2 is 352. So yes, it's further divisible by 2. 16 m squared, and then this would be 56, I think. Why does it... 56 times by 2, this is 112, so 56. And 352 divided by 2 is 176. So I think we can keep going over here. I think, is it further divisible by 8? Right, okay, so 8, 2m squared, 8 times by 7, and then 22 equal to 0. Right, I think we can solve this now. So 2m squared minus 22 minus 7m, so only 11 and 2 can give us 22. And yeah, okay, so 11m minus 4m, so 11 is, okay, so you have 2m minus 11 and m plus 2 equal to 0, so either m is 11 over 2 or m is minus 2. Right, okay, done. Oh, we also did the b part. So over here was the ending of the b part. Okay. Now after that was to find the possible pairs of points P. Okay, so C part started over here. So M is this. M is this. So M is this. We need to use M is this. Right. Now we can just simply plug in. We have the now, so either it's 11 over 2x plus 1 or y equals to minus 2x plus 1. Right. So what do we do over here? Okay, I think we would need to just simply plug them into the function. There is no other way to get that. Alright, so we have x plus 2 and we put it over here. Do we have y squared? Okay, we can do it in the squared one. No, there should be an easy way to do this. Oh right, we already did some of the working. Okay. So you see, we can find two values of x by just plugging it into over here. Right, because we now know the m. Okay, so so let's copy this over here. So you have m squared plus 1 x squared, and then plus 4 minus 28m x plus 180 equal to 0. Alright, this solves us a lot. This saves us a lot of trouble. So y is either 11 over 2, so you get 121 over 4 plus 1 x squared plus 4 minus 28 times by 11 over 2 plus x 180 equal to 0. So you have 4 over 4, so that is 125 over 4 x squared plus 4 minus 28 times by 11 divided by 2, that is minus 150, just simply, plus 180 equal to 0. Right, so easy way to handle this is just simply divide this by, first we can do multiply by 4 on both sides. We make all of them integers, so you get 125. 150 times by 4 is 600, and 180 times by 4 is 720 equal to 0. Now we can divide by, can we divide by 125? Can we divide by 25? Wait, can we divide 720 by? No, we can't divide by, right, okay. Right. Okay, let's divide by 5 then. 600 divided by 5, that is 120, so 25 x squared minus 120x plus 720 divided by 5, that is 144. Okay, so 5, this is the square of 5, this is the square of 12, so 5 and 12, 60 and 60 times by 2. Okay, so this is easy, this was easy, so 5x minus 12 whole squared equal to 0. So this would get us x equals to 12 over 5. So if x is 12 over 5, y would be, sorry, no, this is not y, this was m. 11 over 2 times by 12 over 5 plus 1. Okay, so 11 times by 12 divided by 10 plus 1, that is 71 over 5. Okay, so one coordinate is this. Okay, now we need to use m is equal to minus 2. So minus 2 whole squared plus 1, 4 plus 1, 5x squared, 4 minus 28 times by, so that is 4 plus 28 times by 2, 60 x plus 180 equals to 0. Divide both all of these by 5. So 60 divided by 5 is 12. 180 divided by 5 is 36 equal to 0. So 4 and 9 6 and 6, yeah, so 6 and 6 is x plus 6 whole squared equal to 0. So x equals to minus 6. So y is minus 2x plus 1 in this case. So minus 2 times by minus 6 plus 1, so 12 plus 1, 13. So possible coordinates are 12 over 5 and 71 over 5. And the other one was minus 6 and 13. Okay. So this was a long question. Right, okay. Prove by counterexample that the statement if n is a prime number, then 3n plus 2 is also a prime number. Okay. So basically we just need one example where this does not hold. Okay. So we can start with n prime numbers, so primes, so basically 1, 2, 3, 5, 7, then 8, 9, 10, 11. So 3, 1 plus 2, 5. This is a prime. So 2 raised to the power 1, so 2. Sorry, 3 raised to the power 2. So 9 plus 2, 11. 3 raised to the power 5. Sorry, what am I doing? 3 raised to the power 3. 27 plus 2. 29. Also a prime number. 5. 3 raised to the power 5 plus 2. So 3 raised to the power 5 plus 2 is 245. No, it's not divisible. Not a prime. So not a prime. So prime, prime, prime. So this is n is equal to, n is equal to, n is equal to, n is equal to. So we don't need any further examples from this. So hence, yeah, so hence we can say this rule is not true. Hence, actually we can use a full statement over here. So when n is equal to 5, 3n plus 2 is equal to 245, which is not a prime number. Therefore, this rule is not true. This statement is not true. Okay, alright. Use proof by exhaustion to prove that if m is an integer that is not divisible by 3, then m squared minus 1 is divisible by 3. Now this is a very fun question over here. So for example, if you have any number, for example, divisible by let's say number n, then any number divisible by n would be a multiple of n, right? This would mean this is a multiple of n, right? However, any number that is not divisible by n would give you some remainder. So some remainder, right? And this is usually goes from 1 to n minus 1. Oh, sorry, actually we did not need to do that. So remainder would be remainder would always be from 1 to n minus 1. So for example, you have number divisible by 3 that will be a multiple of 3, right? So k is any integer, just like in the previous one. So this means that this is a multiple of 3. So not divisible by 3 would mean that you have 3k plus some remainder. So remainder could be 1, 2, because you see it goes from 1 to n minus 1. It could be 1, it could be 2. So m could be 3k plus 1, and k could be 3k plus 2. So if you do 3k plus 3, it would become divisible. So you can either get a remainder of 1 or a 2. Now, that is not divisible by 3, then m squared minus 1 is divisible by 3. Okay, so let's test these two relationships. So when m is equal to 3k plus 1, then m squared would be 3k, 3k plus 1 whole squared minus 1. So this would be 9k squared, 6k plus 1 minus 1. So this leads to 9k squared plus 6k, because 1 cancel out. So you can just rewrite it as 3k squared plus 2k. Now 3k squared plus 2k is basically an integer, so yes, it is divisible by 3. So therefore, divisible by 3. So divisible by 3. 3k squared plus 2k is divisible by 3 because it is a multiple of 3. Now, when m is equal to 3k plus 2, so therefore m squared minus 1 would be 3k plus 2 whole squared minus 1. Right, now let's do expand. 9k, 3 to 6, 6 2k plus 4 minus 1. So you get 9k squared plus 12k plus 3. So write it as a multiple of 3, so you get 3k squared plus 4k plus 3. So therefore also divisible by 3. Divisible by 3 also. So therefore we have shown that in both the cases it is divisible by 3. So both the cases are multiples of 3, so that's basically it. So we need to write this. So therefore, when m is not divisible by 3, m squared minus 1 is divisible by 3. Right, and that is the end of this paper. Hopefully you enjoyed this. This was a long one. I got also tired. However, I hope you enjoyed the explanations. If you have any questions, doubts, or confusions, feel free to reach out in the comments. I would love to hear your feedback also. If you like this video, do give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates, because we regularly post question papers walkthrough regularly. So meanwhile, see you in the next video. Bye bye.